Okay, so I've got a little thing to go over here. I've labeled it Identify Outliers, but what I really want to do is show you how to make a ggplot2 object interactive and show you a way to squeeze a lot of information out of your interactive graph. Okay? So let's see, first thing we have to do, get started. Follow up to models and visualization, which we did in class. Okay, in the setup, there's one thing that you need to include that we haven't done before, which is Plotly. So you need a library Plotly in here, and of course that implies that you have to have done an install.packages Plotly earlier. Okay, because that's the thing that we're really focusing on. Okay, so start by recreating model B and the graphic showing the outliers. If you really wanted to be an active learner, you could go look at model B again and just get it going on your own without relying on what I'm doing. But I'm just going to go ahead and assume that you've done that. So you're looking at a version of model B. And here it is. It's simply a second degree polynomial in displacement. That's the only thing to the that you're saying that city mileage depends on. And you do the thing with getting the residuals and the fitted values into the data frame. Okay. Then we do the graphics. And you see the points that we were chasing were really these. These are really irritating. It looks like you have an awful lot of some extreme outliers at the high end at very low values of displacement. So we're going to see what we can do about those. So you can use Plotly to make a plot interactive, and here's the way you use Plotly. First, instead of just using ggplot2 to produce a graph, you use ggplot2 to produce a ggplot2 object. We call this one P. And then you apply the function ggplotly, which is part of the Plotly package, to P, and then you get this. Now it looks just like it did before until you put the cursor in it, and then you see a bunch of extra stuff show up. Now I don't care so much about all the extra stuff, but we want to look at what happens when we excite the tooltip, that is, to hover over or near a point. And it tells me what those values are for that point. It says this is a displacement of 1.9 liters and city miles per gallon of 35. Okay, and you notice that that's very much higher than the predicted value, which is down around here. Okay. It's not very useful because the default tooltip only shows the plotted values. But here's the second big trick in this little presentation, is how to supply extra information to the tooltip provided by ggplotly. Okay, so in the aesthetic, when we created the object P, before we just had X as displacement, Y as city, and then I've got some other things here. So visual label 1 is equal to a variable in the data frame called trans. Visual label 2 is equal to a variable in the data frame called drv, and so on. And then I do the same thing as I did before with ggplotly. And let's see what changed. Well, now when we go to look at the tooltip, oops, went too far. Sorry, I didn't mean to get to model C yet. But when we get into this graph and look at it, that's not the right graph. It's this graph. Now look, and now what I see when I excite the tooltip, I get not only the displacement and the city mileage, but I get all those extra things that I associated with labels. Okay? So what are these two weird things? Well, what I see about them is that they're small vehicles. They have a displacement of 1.9 liters and a 5-speed manual transmission. That to me is what I call an econobox. Okay? So this is that was the important thing I wanted to show you in this presentation. I'm not trying to teach you about models. I'm trying to teach you about visualization. So when we take advantage of that information, let's see what happened. We've got an improvement in the fitted value at 1.9 liters from about 22 to about 25. Okay? So that is using ggplotly. I hope you enjoy it. You'll find it useful at some point, I'm sure.